Hello, Algebra 2 local students. We're coming at you right here with some more geometric sequence practice, but you'll notice actually at the start of this day of notes that we're going to mix in some arithmetic sequences as well. And I know that there was a little bit of that on the last homework that was assigned, so you can see that at the top we've listed what both of the general formulas look like. Here's the arithmetic, there's the geometric one. So hopefully this one isn't too far removed from us. And like I said, that last homework had a little bit of practice. This is the one we've been focusing on lately with our geometric patterns. So what I'd like us to do is maybe take a quick look here at filling in some sequence patterns, figuring out, is it arithmetic or geometric, which I think this chart looks similar to what we did at the end of the last set of notes too. Tell me the difference or the ratio depending on what kind it is, what's A1, and then what's A8. So in the first example, we have 2, 6, 18, and 54. This actually, I'll tell you, would have been a warm-up if we were in class. But since we're not in traditional class, if you want to try this on your own, since you've seen something like it before, go ahead and give it a shot, hit pause right now. But otherwise, if you just want to kind of follow along, that's okay too. So this is going to be a geometric sequence with an R value of 3. Okay, if you notice the pattern, you're multiplying by 3 each time. And then the first term of this the sequence is 2. The reason why I'm having you specifically list out that first term is that that is going to be something that we plug in to find the 8th term of the sequence. So A8 would equal A1, which is 2, times the ratio 3 to the 7th power. And if we type that in the calculator real quick, 2 times 3 to the 7th is going to be an answer of 4,374. Okay. So we've got that taken care of. Moving on to the next one, -5, -2, 1, and 4. This one, if you look at the pattern pretty quickly, hopefully you can see that we're not multiplying by 3 anymore, but we are adding 3. So this is an arithmetic pattern with D equals 3. A1 is -5. So to find the 8th term, you're going to do A1, which is -5, plus, now you're going to add on that difference of 3 7 times. So it's going to be 7 times 3 at the end. And -5 plus 21 should be a total of, in this case, 16. Okay. Look at the next one, 3, 5, 8, and 13. You're definitely not adding the same amount. This is adding 2, adding 3, adding 5. And then if I try and check if it's geometric, 5 over 3, is that the same thing as 8 over 5? Turns out it's not quite the same. Even though you're like, oh, it's 1.6 repeating and 1.6. Definitely not the same decimal. Go out to 13 over 8, you'll see, yep, definitely not the same ratio. So what turns out here is that this is neither of the two. It turns out it is a special sequence. There's something called the Fibonacci sequence. So if you're curious, you can look it up. You might have even heard of it before, but basically, if you take the previous two terms, the 3 and the 5, and add those together, you get 8. And 5 plus 8 is 13. So the next term, if you wanted to find it, would be 8 plus 13. So it should be 21 at that next spot. All right, this one is, next one, 45, 40, 35, 30, is going to be arithmetic, but just be careful because since the terms are decreasing, D is -5 in this case. So A1 is 45. And to get to the 8th term, you would do A1, which is 45, plus 7 differences of -5. And 7 times -5 is -35, plus the 45 is 10. And to be honest, you can probably just as easily, decrease by 5 a couple more times to get to that 8th term of 10. But if I asked you for the 100th term in that list, you'd probably want to use the sequence formula. Last one, 100, -50, and 25. When the terms are decreasing, it sometimes is arithmetic with a common difference that's negative. But if they alternate signs like this, the only way that can happen is when it's geometric. And in this case, the R value is -1/2. Or if you wanted to write -0.5, you could do that too. So A1 is 100. The 8th term would be A1 of 100 times R to the 7th power. So that 8th term is 100 times negative. You could put a 0.5 in there if that makes your life easier, especially if you're doing this on your phone. I don't really love that decimal. I mean, it's fine. You can write out the whole thing, -0.78125. But if I math frac that, for some reason, I like this answer better, -25 over 32. So if you like the decimal better, totally fine there, guys, but mathfrak works just as well. All right, so then there's some quick practice here. This one says at the very bottom, find the indicated terms. So what I was saying before is, in this list up here, if I ask you to find the 100th term, you don't want to keep subtracting 5 in your head. So if I give you A1 and I give you D, first thing you have to know is that this is arithmetic, because arithmetic sequences have a common difference. To find the 100th term, it would be A1 plus 99 common differences. Okay. Remember, this number next to D is always the difference in the term numbers that you're working with. 100 minus 1 is 99. Okay, so we know that A1 is -2. We know that the common difference is 7. So typing that into the calc, -2 plus 99 times 7 is 691. It would take me forever to keep adding 7 to get there, so you can see the advantage to developing this arithmetic sequence pattern. If A1 equals 1/2 and R equals 2, now you should be thinking, hey, this is geometric. If I tell you R, what's the 13th term? Again, could I keep multiplying by 2? Sure, but I don't think I really want to. In general, this is what the formula would look like to find the 13th term if you know A1. So A1 is 1/2. The ratio is 2. 1/2 of 2 to the 12th. Be really careful. Don't do the 1/2 times the 2 first. That would be breaking PEMDAS. We don't want to do that. So the answer here is 2048. Okay. So hopefully we're doing pretty good so far with some of the patterns and remembering how do we use the arithmetic and geometric formulas. On the back, there's some more practice. I'm going to do a couple of these with you. I won't fill them all in, and I'll tell you that the website will have the rest of these posted. But just as a quick note about number 3, this one's a little bit different because you're given A7 and A13. So you don't know A1 anymore. And all the other cases we've looked at so far, you've known A1. But it does say to find D. So again, if we're finding D, this has to be an arithmetic sequence. And what I mentioned just a moment ago is that in an arithmetic sequence, if you know A13 and you know A7, the number of times you add on that common difference is the difference in these term numbers. So 13 minus 7 would be that you're adding on the difference 6 times. And that is a skill that you would have used a lot in the arithmetic sequences unit. So if it's looking familiar, that's a good thing. All right, go ahead and plug in what you know. A13 is 45. A7 is 21 plus 6 differences. Just remember that the solve for an arithmetic sequence looks pretty different than solving for a geometric sequence. In this case, you're going to subtract 21 from both sides. So 45 minus 21 is 24 equals 6D. And then to solve for D, you're going to divide by 6 and get that the value of D is 4. Okay, knowing that the common difference is 4, I now want to figure out what was the first term of the sequence. What's A1? So to find A1, I'm going to use one of the terms that I know. So I'll use A7. A7 would equal A1 plus, in this case, also 6 differences, right? Because 7 minus 1 is 6. So A7, oops, sorry, we know that. That's 21. I'm looking for A1, and the common difference is 4. So 21 equals A1 plus 24, and then A1 is going to equal -3. Okay. All right, I'm going to skip this one, and I'm going to skip this one. I'm going to do number 6, though. So I'll tell you 6 and 4 are very similar questions. They're both geometric, and 3 and 5 are kind of very similar questions. They're both arithmetic. So if you want to go and practice these, I would highly recommend it. And then again, the answers will be filled in on the website. I just won't fill them in the video right now. So we take a look at number 6. The idea here would be, you know A4, you know A7, find the common ratio, and then we'll find A1. So for a geometric sequence, A7 would equal A4 times R to the what power? Well, the difference, 7 minus 4, would be R to the 3rd, or R cubed. So A7 is 15,625. A4 is 125. All right, the difference between doing arithmetic and geometric is right here. Instead of subtracting the 125 over, since we're multiplying by 125, to get rid of it, you have to divide it from both sides. So in this case, 15,625 divided by 125 is, what do you know, 125. So we get 125 equals r to the third. And then, as a quick reminder, the way we get rid of raising something to the third power is you raise it to the reciprocal power. Be careful when you type this in on your calculators or on your phones. You know, you'd probably have to put 1/3 in parentheses to get the right answer. If you have a graphing calculator at home and it makes that nice little exponent for you, you won't have an issue. But you should be getting an r value of 5 here. You know, play around with your calculator, or if you're using your phone as a calculator to see, you know, specifically since you know the answer is 5 in this one, what notation you need to use to get that answer. Okay, if r equals 5, let's use, you know what, I'll use a7 this time. So a7 equals a1 times r to the 6th. Remember, a1 is what I'm looking for now. a7 is 15,625. And we just figured out that r is 5. So you can type in 5 to the 6th if you want. 5 to the 6th is, oh, that's interesting, 15,625. Okay. So if this number is 15,625, if I divide that over to the other side, remember we're not subtracting. You're going to divide that over. When you divide something by itself, you're going to get, in this case, that a1 equals 1. Okay. So like I was mentioning, this is very similar to what you have in number 4 here, and 3 and 5 are pretty well connected. So hopefully that will make sense if you try those for practice. At the bottom of this page, we have one question about geometric and one about arithmetic means. So I'll remind you how to do those just to make sure we're okay with the process. And then the last thing we're going to talk about in this lesson is some real life applications involving arithmetic and geometric sequences. So for number 4, find for 7, find 4 arithmetic means between 2 and 37. So the setup for something like this is we have 2 blank 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 37. So I want to figure out what are those 4 missing terms right here. Remember that 2 is of course the first term, but what's 37 all the way down here? This is going to be the 6th term, because count them, 2, 3, 4, 5. This is going to be the 6th term right here. So how do we figure out in an arithmetic sequence what I'm adding each time, that common difference? Use the 2 terms that you know. It's pretty similar to what we did up at the top. A6 will equal A1 plus 5 differences. So 37 equals 2 plus 5d. All right, 35 equals 5d. When I subtract the 2 over, dividing by 5 gives you d equals 7. Now remember that the answer to this question is not just the value of d, it's what those 4 missing terms are. So let's see how carefully I can add 7 here. 2 plus 7 is 9, that's the easy part. 9 plus 7 is going to be 16. 16 plus 7 is 23. 23 plus 7 is 30. And if I do that last check, 30 plus 7, yeah, that's 37. So these are the 4 answers. 9, 16, 23, and 30 are the 4 arithmetic means there. Really similarly for geometric means, it says there are 3 of them in this one. You're going to put 3 blank spots in between 1 and 256. Since there's only 3 blank spaces this time, the last term is A5 and 1 is A1. So the setup would be A5 equals A1 times r to the 4th. 256 is A5, A1 is 1. You would really technically start by dividing both sides by that A1 value, but dividing both sides by 1 doesn't change anything, right? You get 256 equals r to the 4th. And remember, the operation to get rid of the 4th power is raise it to the 1/4. So 256 raised to the 1/4 power is 4 in this case. If you're getting some really crazy decimals, what do I mean by crazy decimals? Something that's not like 0.5, 2.5. 0.75 is 3/4. That's not so bad. If you get these really nasty looking decimals, most likely you're making a mistake potentially on the calculator there. Okay, so r equals 4. If I go ahead and go back to my sequence and multiply by 4, this would be 4, right? 1 times 4. 4 times 4 is 16. 16 times 4 is 64. And if you check it on the calculator, that last step, 64 times 4 is in fact 256. Okay. Last thing we'll do is really quickly take a look at some applications of arithmetic and geometric sequences. We've done this with arithmetic before, and we've done a little bit with geometric, but now I think the main goal will be, how do we choose? Which one is it? Are we adding a constant amount each time, or are we multiplying by something each time? And we'll try and underline the keywords that would help me to determine that. So the first day of sales, Girl Scout Troop, 3.14. Oh, how nice, 3.14, Girl Scout Troop pie. Okay, is selling, they sold 10 boxes of cookies on the first day. Well, so that sounds like A1 to me. A1 is 10. Each day after, they sold 2 more boxes. So the next day they would have sold 12 boxes. And then the day after that, they would have sold 14. So if I'm selling 2 more boxes than the previous day, this is an arithmetic sequence with D equal to 2. How many boxes of cookies did they sell on day 30? So on day 30, that would be the 30th term in the list. That's what I'm trying to find. So in an arithmetic sequence, A30 would be A1 plus 29 differences. So that would be 10 plus 29 times 2. 29 times 2 is 58, plus the 10 is 68 boxes of cookies. And as I'm doing this question, I'm looking on top of my refrigerator, and I can see some Girl Scout cookies calling my name right after this lesson. Okay. Number 10, the population of fish in a pond doubles. Okay, doubles, triples, quadruples. Those are going to be keywords that indicates that this is a geometric sequence. If you're multiplying by 2, okay, that's my R value here. If there are 12 fish at the start, there's my A1. How many fish are in the pond 7 months later? So I'm looking for A7. So in a geometric sequence, A7 equals A1 times R to the 6th. So A7 would be, in this case, 12 times 2 to the 6th. It's going to be a lot of fish here, guys. Let's say 12 times 2 to the 6th is 768 fish in the 7th month. Okay. Last 2 to do. After year 1, your car is worth $30,000. Year 2, it's worth $24,000. Year 3, $19,200. How much is it worth after 7 years? So to determine the pattern here, if you're not sure, first check arithmetic. What do I have to subtract to get from here to here? You're subtracting 6,000, right? From 30 to 24,000. If you subtract 6,000 again from this number, you would be at 18,000, which is not the value of the car in year 3. So I'm thinking what's happening is that this is geometric. In fact, I think we've done a question like this already earlier in the notes. So if I take 24,000 and I divide by 30,000, and you have to do the second term divided by the first, you get 0.8. Let's double check that 19,200 divided by 24,000 is also 0.8, and it is. So this is a geometric sequence whose ratio is 0.8. The first term is 30,000, and I want the value of the car after 7 years. So actually, again, in this one, we're looking for A7. So if A7 equals A1 R to the 6th, 30,000 times 0.8 to the 6th power is, let's see if this seems realistic here, guys. The car would be worth $7,864.32. Might be realistic. That 7 years later, you can sell your car if you keep it in good condition here. Okay, and I'll put the change on that, right? Because it's an amount of money. You probably wouldn't buy it with that, for 32 cents extra, but we'll put it on there because it doesn't say anything about rounding in this one. Last one, at the start of spring, your garden has 55 daisies. So that's A1 at the start. And each day after, there are 3 more daisies that wilt away. Oh no, wilt away. Hopefully what you're implying with wilt away here is that the daisies are going away or decreasing. And if 3 more do that each day, this is a common difference of -3. Okay, students get caught up on that all the time. So if they're going or wilting away, it means they're kind of dying, right? So we're decreasing by 3. How many are left after 14 days? So A14 would equal A1 plus 13D. So A1 is 55. D is -3. So 55 plus 13 times -3 should be 16 daisies are left on day 14. Sorry, daisies. They're dying off here. Okay. So that's it for today. You'll see that the rest of this week you'll have some review and practice with this material. And then eventually we'll be sending you out a quiz that we want to see. Just make sure that you complete that and see what kind of practice you've been getting with arithmetic and geometric sequences. All right, thanks for listening in, guys, and certainly email if you have any questions.